Hi everyone, welcome back. Jun Rao from Confluent here. In this module, I'm going to go through the tier storage within Kafka. This is actually a feature that's available in Confluent right now, but it's being developed in Apache Kafka as well. So before I talk about tier storage, let's first review the current Kafka storage and talk about some of its limitations. So this is how Kafka stores data now. Each broker has some local attached storage, and then all the data in those topic partitions will be stored among those local storage in those brokers. Now, what are some of the issues with this? The first potential issue is in terms of cost. Kafka is really designed for some real-time applications, right? So for the most recent data, it makes sense for them to use fast type, potentially more expensive local storage. But for some of the historical data, it's a little bit wasteful to use the same type of storage because that can add up the cost. So that's the first potential issue. The second issue is in terms of elasticity. Because we have coupled the storage with the broker computation, now if we want to scale out the storage and the computation, we can't scale them out independently. For example, if we need more storage capacity within the whole system, since the local storage capacity is limited, the only way we can do is to add more brokers. That means those brokers are just adding some new computing resource that's unneeded. The last part is in terms of isolation. So earlier I mentioned that we use zero copy transfer to transfer data in the local storage all the way to remote socket. Now, if the local data is not in a page cache, this can be expensive because it needs to load the data into the socket, and that can take time. It can block network threads, which means this can impact some real-time consumers that's assigned to the same network thread. So the isolation is also potential issue here. Now let's look at how tier storage is designed and how it solves some of the issues. So with tier storage, we no longer have a single type of storage associated with the broker. Instead, the broker storage is tiered. For the most recent data, we can continue to keep them in the local fast storage. But for the historical data, we can potentially archive them into remote object stores, and there are quite a few from various vendors. And then we only need to keep the references of those remote objects in each of the brokers. Now, what's the benefit of this new architecture? First of all, in terms of cost, because we only keep the most recent data in the local store, we only need to pay the high-end fast storage for a small portion of the more recent local data. For the vast majority of historical data, we can use potentially the cheaper object store, but they still can provide pretty good throughput for our usage. The second thing is benefit is in terms of elasticity. Now, since we have separated the storage from the compute of the brokers, we cannot scale them out independently. For example, if we only need more storage, we don't need to add more brokers because the object store is potentially infinite, can keep expanding with the storage space. If we do need some more computing resource by adding new brokers, this process can be done much more efficiently because we only need to physically copy just a small portion of the local set of data, the more recent data among the brokers. Or the rest of the historical data, we don't need to copy some references, which is much faster. Lastly, this also provides a good opportunity for us to provide better isolation, because since now the historical data will be stored in a different remote object store, we can serve them in a completely different path from the local data, which will potentially provide much better isolation between the real-time consumers and consumers that access historical data. Now let's look at in a little bit more detail how tier storage works. When you publish data to a tier storage enabled topic, the producer doesn't change. You still write data to the leader, and the data will be replicated to all the followers. That stays the same as before. But over time, as new segments are being rolled, what a broker will do is to start archiving those rolled segments into the remote object store. Once the segment is uploaded into the remote object store, the leader of that partition will also be writing the metadata of that remote object into an internal topic. And all the other replicas will be reading this remote metadata information from this internal topic, and then they will be using that to build their internal in-memory view of the remote references. Once the data has been successfully archived to the remote object store, the local data can be removed because we don't need that redundantly in the local log. And how long you want to keep the data in the local log can be configured by this retention time. And typically, maybe an hour or maybe 10, 15 minutes is enough to keep the local data. From the remote references and the locally stored log segments, each broker has a holistic view of all the segments it has in its log. Some of them will be only in the remote store. Some of them will be only in the local storage. Some of the segments could be in both places. But the broker will have the exact view. So when the consumer wants to fetch a particular offset, it knows from which part to give the data back to the consumer application. Now let's take a closer look at how the fetch request is served with tier storage enabled. When the consumer issues a fetch request with a particular offset, if that offset falls into the local storage, the data can still be served in the same way as before. And in this case, since we can configure a relatively small local retention storage, the chances are that all the local data will still be in the page cache. If the data is only in the remote store, what the broker will do is it will first streaming the remote object data from the object store all the way into an in-memory buffer within the broker. And from there, it will stream the in-memory data back to the remote socket in the network thread. This way, the network thread is no longer blocked even when the consumer is accessing some historical data. This actually makes it very convenient to mix applications that access both real-time and historical data in the same Kafka cluster because they won't be impacting each other. Tier storage is also designed to be portable. It supports the object store in all the major public cloud, but it also supports some of the object store even for some of the on-premise use cases. So it provides the ability for you to leverage this feature whether you're in a public cloud as well as in the private cloud. And that's it for this session, and thanks for listening.